Hi, I'm Kiran Kumar from Nature of Physics. Today topic is Kepler planetary motion. Step by step, very detailedly, clearly explained and also with the numericals. Please do like and subscribe our channel Nature of Physics. See student, law of orbit first one, that is Kepler first law. Second one is law of area, second law. Third law is law of period. Okay student, first law of orbit. All the planets are revolving around the sun in an elliptical path with sun at any one of the focal point. See there, this is the elliptical path student. In the elliptical path, sun is at any one of the focal point. This is the first focal point and this is the second focal point. See there. So first focal point sun is there. Okay, and all the planets are revolving in a elliptical path. Okay student, and in this here we are representing for elliptical path two radiuses with respect to center. One is representing, okay, A is the semi-major axis and B representing semi-minor axis. See, written already, semi-major axis is A and semi-minor axis is B. Okay, and also next eccentricity is representing with letter E student, the ratio between the two different line segments student. So that the eccentricity I am going to write here E, which is equal to OS divided by OA student. Eccentricity is defined as the ratio of OS, see clear in the diagram, to the OA student. Okay, now next step, eccentricity OS, which is equal to E into OA. But OA represent, what is that there? OA represent the semi-major axis student. So that E, which is equal to, okay, sorry, OS I have to write. OS, which is equal to E into EA student. And also I have to explain the two positions of the planet. One is the perihelion position and second one is the aphelion position. Perihelion position representing letter P and aphelion position representing letter A. Perihelion position is the shortest distance between the sun to the position of the planet. So that radius is representing RP. RP is the shortest radius between the sun and the planet at the perihelion position. Okay, and also aphelion position, that is the largest radius from the sun to the planet. See there clearly represented RA. So from the center of sun to the position of planet, maximum radius representing, what is that student? Aphelion position. So A represent aphelion, P represent perihelion position. So I got OS is equal to EA student, and then continuation step I am going to find the RP and RA step by step student. First I wanted to find about the RA position, so that RA writing student, RA which is equal to, so this is the distance sum of the O to S to the O to A student. So that RA writing as OA plus OS. So I got OS is equal to how much student? E into A. So that RA which is equal to OA plus EA. One more step writing, actually OA represents semi-major axis. So RA which is equal to A common. So 1 plus E student. This is representing largest radius for the aphelion position of the planet from the sun. Okay, and next continuation step is, that is perihelion position radius is finding with respect to sun student. So for this I am going to write here RP which is equal to, that is total distance from the center to the planet is OP, and the distance less than from O to S, that is minus OS student. OS is equal to EA, so that RP which is equal to OP is written as A minus EA. So that RP which is equal to A common student, so that 1 minus E student. See there two equations I got. One is the aphelion position radius and second one is the perihelion position radius. So I can write this is equation number 1 and this is equation number 2, student. Okay, and continuation, next step I am going to explain the position, aphelion and perihelion radius ratio finding, student. RA divided by RP finding, student. So RA is representing A of 1 plus A divided by RP representing A of 1 minus E. AA get cancelled, so I got RA divided by RP, which is equal to 1 plus E divided by 1 minus E, student. This is I can write as equation number 3. Okay, student. And also continuation step, next one is it obey the law of conservation of angular momentum, student. Okay, wait a second. Yes, student, and continuation step, now we will discuss about the law of conservation of angular momentum. So simply writing law of conservation of angular momentum. Okay, that is initial momentum which is equal to final momentum. So that initial momentum is m1 v1 r1, which is equal to final momentum m2 v2 r2, student. But one planet only we are considering, that's why the mass is same, student. So that m of, so first position I am considering perihelion position, so that Vp. Okay, and that corresponding radius is Rp, which is equal to mass is same planet. So velocity at a point aphelion position, so that Va, that is radius is representing Ra, student. See clearly. Okay, so this position is I am representing as aphelion position. Okay, aphelion position, and this position is representing what is that, student? Perihelion position. Clear equations already written, student, and mass is get cancelled both side. And then continuation step I am going to write here velocities Vp Rp, which is equal to Va Ra. Then I will write the Vp divided by Va, which is equal to Ra divided by Rp, student. One thing you have to notice clearly here. So this is Vp value represent, okay, that is the maximum velocity, divided by Va represent minimum velocity, which is equal to Ra represent, that is maximum radius, divided by Rp represent minimum radius, student. Okay, so that the corresponding equation again I will write just for clarity purpose, student. So that Vp represent the Vp max and Rp represent the minimum radius, which is equal to Va velocity at aphelion position is minimum and radius of the aphelion position is maximum. So that using this equation and values also replacing, student, so that Vp divided by Va, which is equal to Ra value is, we got A of 1 plus E and Rp value we got as A of 1 minus E. So AA get cancelled, student. So I got here Vp divided by Va, which is equal to 1 plus E divided by 1 minus E, student. Here one thing you have to notice clearly, Vp velocity at perihelion position is maximum, velocity at aphelion position is minimum, student. This is clear information about the law of orbit, and one numerical is there. Wait a second please. There is one problem. Find the ratio of velocity and their kinetic energy at position 1 and 2. So that angular momentum we have to find, student. So for this, positions are representing, this is the perihelion position student, and this is the aphelion position. See there, velocity at the perihelion position is Vp, velocity at aphelion position is Va student. So this is representing radius of the perihelion position, and this is representing radius of the aphelion position, clearly given. So what is asking in the question? Find the ratio of velocity and also kinetic energy of position 1. This is position 1 student, and this is position 2. Okay, so that clearly represented already diagram. P represent perihelion position, A represent aphelion position, velocity Va and Vp. So velocity at the perihelion position is maximum, velocity at aphelion position is minimum student. So that the value is replacing in the law of conservation of angular momentum. See there clearly. So according to the law of conservation of angular momentum, so that m of Vp Rp, which is equal to m of Va Ra. So in this, m is get cancelled student. So Vp divided by Va, that is equal to Ra divided by Rp. See clearly. So this Vp by Va represent the V1 position divided by V2 position. First position is perihelion, second position is aphelion position. So which is equal to, the value is represented, Ra is equal to how much given? 6 divided by Rp is given as 2, once 3 times get cancelled. So that V1 by V2 I am getting 3 divided by 1 is the answer student. And continuation step is there. We need to find the kinetic energy also. Okay, so kinetic energy Ke1 divided by Ke2, which is equal to half m1 V1 square divided by half m2 V2 square student, which is in which masses are same. So same planet, that's why masses are same. One more step writing, half is get cancelled, m by m. So V1 divided by V2 whole square, mass is get cancelled. So that kinetic energy 1 divided by kinetic energy 2, which is equal to V1 square by V2 square. So that V1 by V2, how much we got? 3 divided by 1. So that kinetic energy first position divided by kinetic energy second position, which is 9 divided by 1 is the answer for the given question. See student, continuation, second law I am going to explain. Law of area. The line joining from the planet to sun, line joining from planet to sun, sweeps out equal area in equal interval of time. See there student, like this, P1 position to P2 position and P3 position to P4 position, both areas remains same, because of time taken from P1 position to P2 position is equal to time taken from P3 position to P4 position, covering equal area in equal interval of time. So that I can write here dA divided by dt, which is equal to constant. So that according to the diagram I can write dA1 divided by dt, which is equal to dA2 divided by dt, which is equal to constant student. See there. Okay, but one thing you have to notice, at P1 position, that is the aphelion position, radius is maximum, and this P4 position approximately represent the perihelion position, radius is minimum. So that area divided by time is remains constant, that we can call as aerial vector student. What is that? Aerial vector. Aerial vector represent dA divided by dt, which is equal to constant. Okay, see student. And continuation, next I am going to explain the derivation for the angular momentum of the planet of mass m moving around the sun in an elliptical orbit is L. So angular momentum is L, student. The magnitude of aerial velocity of the planet is, what is asking, student? Already I gave you aerial vector. Here aerial velocity, okay, vector is asking, magnitude of aerial velocity vector is acting. I wrote aerial vector, actually that is aerial velocity vector. I did a mistake. Aerial velocity vector, okay, sorry for the mistake. Okay, student, and continuation, next I am going to do the derivation for this given question. Okay, so first I am going to write here dA, which is equal to half into base into height. So that is area which is equal to triangle area, that is half into base into height, student. See there clearly. So small area considering dA, which is equal to half into base is taken as a radius, student. See there in the diagram P1 P2 position considering there, so that this is a radius is r, and height representing position P1 and P2, student. P1 P2 represent the heights, okay, and there is a small angle representing d theta, student. Okay, so that d theta, which is equal to arc length divided by radius. Arc length is representing P1 P2 divided by radius is r, student. So that from this equation I am getting P1 P2 which is equal to r into d theta, student. So the value is replacing in the above equation. So that the continuation step is dA divided dA, which is equal to half into r d theta I got, student. See there clearly. Okay, and then continuation step dA, which is equal to half into r is r square into d theta I got, student. Okay, and in both sides of the equation, so divided by time dt, student, divided by time dt. See for this equation dA divided by dt, which is equal to half into r square d theta divided by dt, student. See there clearly written. Okay, both sides dividing by dt, student. Equation is remains same only. In this equation, this dA by dt give, what is that, student? Aerial velocity vector. So that dA divided by dt, which is equal to half into r square d theta divided by dt, that rate of change of angular displacement is called angular velocity. So omega represent the angular velocity, student. So this is, I can write as equation number 1. So from this equation dA divided by dt is directly proportional to r square into omega, student. And continuation derivation I am going to explain related to the equation 1 here. Small m is multiplying and dividing, small m represent the mass of the planet. So that dA divided by dt, which is equal to half into r square into omega. So small m is multiplied and divided, student. So that dA divided by dt, which is equal to half into, so m r square omega divided by m, student. So that moment of inertia I am getting dA divided by dt, which is equal to half into I omega divided by m, student. Since I can write here I is equal to m r square is the moment of inertia. Okay, student, and continuation here I am going to write L, which is equal to I omega. Yes, angular momentum is the product of, okay, moment of inertia and angular velocity. So that dA divided by dt, which is equal to half into I divided by m, student. So finally I got dA by dt, which is equal to L divided by 2m is the answer for the given question. Yes, now third law, law of period, student. See there, in the law of period, the square of time period of revolution of the planet is directly proportional to the cube of the semi-major axis. So T represent the time period and A represent the semi-major axis of the elliptical path, student. See there, here also represented clearly. This is the R max is the aphelion position, this R minimum represent the perihelion position, and A represent the semi-major axis, student, and Sun is at one of the focal point. Okay, so that there is a problem also is there. First I will explain the concept, after that related problems we will discuss, student. See there, for this the definition is the square of the time period of revolution of the planet around the sun is directly proportional to the cube of the semi-major axis. According to the definition given, T square is directly proportional to the A cube, student. Okay, so this derivation I am going to explain from the equation, that is centripetal force which is equal to gravitational force. The necessary centripetal force is provided by the gravitational force, student. So centripetal force formula is mr omega square, which is equal to gravitational force between sun and the planet is written as G capital M small m divided by R square, student. Okay, so that m is get cancel, so omega square which is equal to G capital M divided by R into R square is R cube, student. See there clearly. So capital M is the mass of the sun. Okay, and next representing this is the planet, and small m is the mass of the planet, clearly written. Fc, the necessary centripetal force is provided by the gravitational force. Centripetal force formula is mr omega square, which is equal to G capital M small m divided by R square. Small m get cancel, but omega value is here angular velocity, that is 2 pi divided by T, student. The value is replacing in the continuation derivation. See there, 2 pi divided by T whole square, which is equal to Gm divided by R cube, student. So that finally I am getting 4 pi square divided by T square, which is equal to Gm divided by R cube. 4 pi square constant, G universal gravitational constant, mass of the earth is constant, so that T square directly proportional to R cube I got. I can write this is equation number 1. Okay, student. And also next step is, that is T1 divided by T2 whole square, which is equal to R1 divided by R2 whole cube, student. And next step, T1 divided by T2 only writing, student. So T1 divided by T2, which is equal to R1 divided by R2 whole to the power of 3 divided by 2. Now I can write this is equation number 2, student. And also sometimes we have to write the radius also. So from this equation, radius equation, R1 divided by R2, which is equal to T1 divided by T2 whole to the power of 2 divided by 3. This is equation number 3, student. Okay, this is the relation between the time period and the R radius, average radius, that is mean radius, student. So I am going to explain about the R representing the mean radius. See, student, mean radius. So R mean, which is equal, mean nothing but average only, that is the position, okay, with respect to sun is taken as R max plus remaining position, perihelion position, student. So that is R minimum divided by 2, average value. R mean, which is equal to this R max represent the RA, student, aphelion position. R minimum represent the, okay, perihelion position divided by 2. So A of 1 plus E and A of 1 minus E divided by 2. So RA value A of 1 plus E, RP value A of 1 minus E. So that R mean value, which is equal to A plus AE plus A minus AE divided by 2 student. So plus minus AE values are get cancelled, so that I am getting here R mean value which is equal to 2a divided by 2. 2 also get cancelled. Finally R mean which is equal to a student, so that the corresponding equation, instead of this equation from equation 1, the value is replacing R is equal to a, so that t square directly proportional to, instead of R I am writing a student, so a cube. This is I can write as equation number 4 student. Okay, so clear information I gave you. And continuation, one of the problem is there related to the law of period student. For this law of period, so the light planet is revolving around the massive star in a circular orbit of radius r. Okay, so that r is the radius given for the planet around the massive star, and t is the time period student. Okay, and there is a condition given. The condition is force of attraction between the planet and star is proportional to the r to the power of minus 3 by 2. So for this problem, given F gravitational force is directly proportional to the r to the power of minus 3 divided by 2 student, but one condition already we did, the gravitational force provide the necessary centripetal force. Okay student, so that gravitational force, instead of that I am writing the centripetal force, but centripetal force is mr omega square is also directly proportional to r to the power of minus 3 by 2. So instead of gravitational force I am writing centripetal force, and centripetal force equation also written there, mr omega square is directly proportional to the r to the power of minus 3 by 2. Basic formula I wrote student, but according to the question small r is equal given as capital R, so that m capital R omega square is directly proportional to r to the power of minus 3 by 2. So m omega value replacing 2 pi divided by t. Okay, so omega value only replaced, omega square is there, that's why omega value 2 pi by t into 2 pi by t whole to the power of 2 is directly proportional to the r to the power of minus 3 by 2 divided by r student. This r from LHS side to RHS side, so that I am writing here m into 2 pi divided by t whole square is directly proportional to the 1 by r to the power of 3 by 2 plus 1. Bases are equal, then the powers are added student, so that m into 4 pi square divided by denominator t square is directly proportional to 1 by r to the power of 3 divided by 2 plus 1 is 5 divided by 2 student. One thing we can clearly notice there, t square is directly proportional to r to the power of 5 by 2. This is the option given. I have no space, that's why options are not written student. So this is 2024 question only, so mains question, so that t square directly proportional to the r to the power of 5 by 2 I got. Hope you understood clearly. Instead of gravitational force I wrote, centripetal force. Centripetal force formula is mr omega square is equal to fg written student. Instead of gravitational force Fg, I wrote mr omega square. Omega is the angular velocity. Please do like and subscribe our channel Nature of Physics.